I have a fraction here, 9/24, or 9 out of 24, and I would like to show an equivalent fraction that doesn't use numbers that are this big. So this probably started out as a simpler fraction, and we've disguised it or shown it as an equivalent fraction and made it big. So what we want to do now is show the root fraction, or the most basic fraction for this, so that it's using the smallest possible numbers. So when we made equivalent fractions before, we multiplied the top and bottom, the numerator and the denominator, by the same amount to make the whole fraction have bigger numbers, top and bottom. So what we're going to do, if we multiply to make the numbers bigger, and now we want to make the numbers smaller, we need to divide both 9 and 24. So let's have a look at what 24ths look like. I've got a grid here that's 8 by 3. This grid represents one whole, and if I show 3, 4, 5, 6, 7, 8, 9/24ths of that fraction is the same as 3 bits out of 8. Okay, so if we think of eighths, what I'm going to do here is the eighths, if we just had eighths, we would just have sticks running up and down. So we wouldn't have these thirds divisions here. We'll just have one column. 1, 2, 3 out of 8. And that is still the same. Two eighths. 3/8 is the same as 9 out of 24. So let's put that back next to 9/24ths. We recognize that that's 3/8 when we draw it out. And using our division, we ask ourselves, what did we do to 24 to get 8? Don't take anything away. Divide. 24 divided by 3 is 8, because 8 threes are 24. So going the other way. So to make 9 into 3, I also had to divide that by 3. So I'm dividing the top and the bottom by the same number, okay? And that's the same as dividing 9/24ths by this number here, 3 out of 3. Now anything out of itself, 2 out of 2, 3 out of 3, 4 out of 4, a million out of a million, 99 out of 99 is just one whole. And when I divide anything by one whole, I'm always going to have that same number, but it's going to be disguised as a fraction. When it's a fraction, 9 divided by 3 is 3, 24 divided by 3 for the bottom is 8. Now 3/8 is exactly the same as 9/24ths, but it is just written as an equivalent simpler fraction. Okay, let's have a look at another one. Let's have a look at 8 out of 12. Coming over here, I need 12ths, so I might do a 4 by 3 grid. 1, 2, 3, 4, 5, 6, 7, 8 bits shaded out of 12. I've gone longwise this time, and that's because I'm using my rectangles perfectly. I'm using my 8/12 to show that to me by eye now I've got 1, 2 strips out of 3 equal size strips. So I'm thinking that 8/12 is 2/3. Check that one, correct. Check that one, correct. So 8/12 is 2/3. Without drawing pictures, what I can do to get this, let's keep with the pictures a little bit. There's my 12ths there. 1, 2, 3, 4, 5, 6, 7, 8. So it's a half and a little bit more. I'm thinking it's 2/3 big, and it will be if I draw this one the same, if I do my 8/12 this way, so if I, rather than that, just shade it in so I can see that this shape is the same, okay, and they're sitting on the same place on the number line, so that's both 2/3 of the way over to 1. Two bits out of 3 over here. Oops, get my pointer tool. Is there. 2/3 is the same as 8 out of 12, 6 out of 9. So 2/3, 3 became 12 by multiplying by 4. Three became 12 by timesing by 4. And going the other way, 12 becomes 3 by dividing by 4. And the times divide factor here is also times divide 4. So to simplify 8, I need to 8/12, I need to divide by 4 to get 2/3. How do I know it's 4 and not something else? That's the trick. So 8/12 is 2/3. I was able to see it on this tool. Okay, 8 out of 12 is exactly the same as 2 parts out of 3. What if I had divided by a different number? Well, I would have got an equivalent fraction. I could have divided by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. So I'm thinking that's equivalent, but I should recognize that 4/6 is better represented by 2/3. It's smaller. So over here, there's 2/3. 4/6 would have got me there. 2, 3, 4. So let's check them all. Yes, they are all equivalent. But if I had taken 8/12 and halved it, I still wouldn't have had the most simplest form of that fraction, using the biggest size pieces, or in other words, the smallest size numbers. So how do I make sure I do it? Well, the key is to divide top and bottom by the highest common factor. So that's the number, a number that multiplies factors of 12 and factors of 8. So the highest one is 4. And let's look at some other examples. Let's look at this one here. 6 out of 48. So let's clear it. 48, I know 6/8 are 48. So let's make a 48 grid. Six bits. I may as well take the strip along there. Alright, so let's just check that I am properly showing 6/48, and I need to simplify it. Gone the wrong way. I'm 8 across there, but I'm 6 down. You knew that, eh? Okay. So I'm thinking there I've got 6 bits out of 48. Just checking. Correct? And that seems to be one strip out of 1, 2, 3, 4, 5, 6, 7, 8. So I think I can simplify that down to an 8. I think 6/48 is the same way as saying one slice out of 8. and that's correct. So let's look at the maths. 6 out of 48. I asked myself, what's the highest common factor that goes into 6? So what times what makes 6? And common factor means that I want the same number the same highest possible number that multiplies up to make 48. Sometimes there's no better place to start than the smallest number in the fraction between 6 and 48, which is 6 itself, because I know that 6 times 1 is 6, and 6 goes into 48 8 times. So I can see that 1/8 is my fraction, because I'm going to be dividing 6 divided by 6. Six divided by 6 is 1, and 48 divided by 6 is 8. So I've got 1/8 here. So let's go back to where we got this problem from. 6 out of 46 becomes 1/8. Let's see if you can do this one here. 9 out of 63. I think 7 9s are 63. So if I divide 9 by itself, 9 divided by 9 is 1. Oops, I need to do that here. Let's clear that one. I was sitting in the wrong place. I correctly did that as an 1/8. 9 divided by 9, 7 9s are 63, and 1 9s are 9. So 9 is my highest common factor, and 9 goes into 9, and 9 also goes into 63. So it's the 1. It is the highest common factor. It's common to both 9 and 63. So if I divide 9 by 9, I get 1. If I divide 63 by 9, I get 7. Looking at this one here, the highest common factor, we're starting with the top number itself. If we divide 5 by 5, we get 1. And I know 30 is divisible by 5. 5 goes into that 6 times. So let's check them all. Tick, tick, tick. Let's try some other ones. 8 32ths. 8 itself goes into 32 4 times, and 8 goes into 8 once. So that's another way of saying a quarter. And if you think about it, 8 is a quarter of the way towards 32. So it is the same as a quarter. 6 18ths. I think 6 divides into both numbers. So 1 out of 3 is the one I want. And 10 out of 100, the common factor is 10. 10 divided by 10 is 1. 100 divided by 10 is 10. Or I knock off a 0 top and bottom. Check, correct. Let's just do one more. These are similar, because 4 seems to go into the bottom one. Let's just try see if we have different fractions. Okay, so 6 out of 54, 6 goes into both. 6 goes into 6 once, and 6 goes also into 54. Now I'm starting to get a bit tired, but I think it's 9 times. 2 goes into 2 once, and 2 goes into 14 7 times. And looking at this one, I can just knock off the zeros and I can see 1/3, which is the same as dividing 10 by 10, and 30 divided by 10 is 3. Checking, all good. I'll just do this one over here. 7 is the common factor, so we'll divide top and bottom by 7. 1 out of 21. 1 out of, so 5 divided by 5 is 1, so I have to divide 50 by 5. Give me 10 on the bottom. 2 divided by 2 reduces to 1, and I also have to divide 16 by 2 is 8. Nothing else. It's the simplest way to write 2/16, 1/8. I've cut it down using division. Didn't like that one. It's because it's not 21 on the bottom. Need to clear that. 7 divided by 7 is 1. 21 divided by 7 is 3. So that's another way of saying a third. Let's do some different ones. Let's find some challenges. I think I will do 18 out of 24. I'm going to do 14 out of 21. And I'm going to do 18 out of 72. If I'm good with my timetables, I can cancel these down and simplify them. The highest common factor of both 18 and 24 would be 6. So I have to divide both top and bottom by 6 over 6. So that goes, 6 goes into 18 3 times, and 6 goes into 24 4 times. 14 out of 21, I can see a common factor of 7. So I'm recognizing my factors here, 7 out of 7. 14 divided by 7 is 2. 21 divided by 7 is 3. So 14 21s or 21sts is the same as 2/3. This one here, 18 I know does go into 72 because I know that 18 4s are 72, but if we can't find that straight away we can use halving. So we can halve 18 to get it down to 9, so in other words we divide it by 2, and I can also divide 72 by 2, and I know that that one is 36. Now because I didn't know fully if 2 was the highest common factor, I can look at 936 and I can say, can I get that any simpler? Can I reduce it down any further? Well, I can see a common factor there now of 9 because I know that 9 4s are 36, so 36 divided by 9 is 4, and 9 1s are 9. So I've got my quarter now. And I do know that 18 4s is 72, so that is, 18 is a quarter of 72. So that is another way of saying a quarter, and I've got it down simpler. If I'm not too clever with my larger times tables, I can do it in sections, just as I can with other various numbers. Let's look at this one. 20 out of 120 out of 125. Not going to work for me. What was I trying to do? Let's do 100 out of 125. I can see multiples of 25 within these numbers here. So 25 4s are 100 and 25 5s are 125. Okay, we'll leave it at that.